We are in Precalculus lesson 1-7, factor with complex numbers. Today's date is September 9th, 9/9/2020. Our objective for the day, who wants to be off of the list of people to be called on? Jaden, yeah.
Let's get it, baby. All right, factor a sum of squares with complex numbers.
There it is. Yep.
Draw the marble.
We should first talk about a difference of squares before we talk about a sum of squares. So this is a formula that we've seen over and over through Algebra 2. Hopefully you have this at least familiar. A squared minus b squared. I have two squares, right? I have an a squared, I have a b squared, and it's a difference of squares because there's a minus sign in between. Does anyone remember the formula for how to factor a difference of squares? No one? Ellery, yeah?
Is it the thing where you square the first? Wait, it's already squared, so maybe that doesn't make sense.
Oh yeah, so you're thinking square the first, double the product, square the last? Yeah, so that's when you have something like a plus b quantity squared, and that's good that you memorized that.
Wait, then is it the one where it just becomes like a minus b times a plus b?
There it is, yeah. Everyone write down a minus b times a plus b. That is our formula for difference of squares. And these two things have a name. Does anyone remember what they're called? And it's fine that you don't remember that, but I'll go ahead and remind us. It's called conjugate pairs. Conjugate just means that they have a different sign in between. One is a minus sign, one is a plus sign. That's what it means to be conjugate. And there's two of them, so it's a pair of them. And Oscar, can you please start your video up again, please? All right. So let's try using our formula on an example just to get us refreshed. So I gave you two difference of squares, 4x squared minus 25 and a 9x to the power of 6 minus 1. Use our formula to go ahead and factor 4x squared minus 25. So notice what we did. We had an a squared and it turned into an a. Essentially, we took the square root, we unsquared it. And then same thing for b squared turned into just b, so we took the square root of it, or we unsquared it. So how do we square root or unsquare 4x squared? Who's got this? So just as a note, we can do some extra math down here. I'm going to go underneath here and say the square root of 4x squared is the equivalent of asking what is 4x squared to the power of something, some rational, some fraction. Do you remember what the fractional exponent is for taking a square root? Anyone? I know, lots of Algebra 2 review right from the get-go. All right, I have a feeling that this is probably just, it needs to be reviewed, so it's going to be to the power of 1/2. And another way of saying that, which is even more helpful for us, is doing both. It's the same thing as asking what's the square root of 4 and what's x squared to the power of 1/2. These are all the same exact way of asking the same question. So what is the square root of 4x squared then? I have it as like the simplest form I can give you right now. What is the square root of 4x squared? All right, let's do the low hanging fruit. Sorry, Ellery, I'm gonna give it to someone else. Otherwise it's gonna be one-on-one teaching lesson. Square root of 4, someone help me. Square root of 4, that 7th grade question. Beverly's awake. No one else is awake. No one knows what the square root of 4 is. Caroline's awake. No one else. Square root of 4. Anyone? No? Okay. We'll go with Beverly. She was first.
No.
2, all right. What about x squared to the power of 1/2? Caroline, you want to try that one?
I don't know.
So whenever I have a power to a power, and here I can write this rule off to the side too. Whenever I have like x to the a, all of this to the power of b, this is equal to x to the power of a times b. So multiply 2.5 for us.
I can't. I don't know. I don't know.
What is 2 divided by 2?
1.
1. So it's going to be x to the power of 1, or even more simply, just x. So that is the square root of 4x squared. The square root of 4x squared is 2x. And I'm a little bit nervous because that's supposed to be Algebra 2 review, and then we're going to go to the next level today. So I'm going to cross my fingers and just hope that we're just slowly waking up for this math. And then we also need to take the square root of 25. So I'll do some math down here. So I'll do maybe a semicolon. Okay, and then the square root of 25, we can hopefully get some more volunteers for that, just to make sure that you're awake today. Who wants to do square root of 25? Who's got it? Yes, Emily has it. And she's also holding up the answer too. Yes, it's what, Emily?
5.
It is, yeah, 5. It's funny because raising your hand, right, guys? All right, so we've taken the square root of both of those, which is the equivalent of getting from a squared to a that's the operation of taking the square root, right? So to get over into our proper form, maybe write this in red, maybe it'll pop out a little bit better. What is my conjugate pair over here? I've done all the math hard stuff. We just kind of have to plug into the formula. This is our A, this is our B. What is our conjugate pair answer for factoring 4x squared minus 25? There's A, there's A. What am I plugging in here, guys? Basically just need to rewrite this with the correct sign in between. I need to get some more people in here. You can't all just be sleeping on me. Let's give it to Sam. The face. Me? Really?
Darn it. What were we talking about?
You're plugging these into the formula. So we have our A is 2x. There's our A. So just say 2x, Mr. Sandell. Okay, 2x. Good job. Okay, what sign do I copy down, Sam?
What?
What sign do I copy down next? I'm just copying down our formula here.
The sign?
Sign, yeah, sign.
Okay, minus?
Minus, okay. And then what's B? What do I write down over here? What's B?
5.
5. Okay, keep going. Now I'm going to do A plus B.
Okay, 2x plus 5.
There it is. There's our answer. Box it. Okay, same exact thing. For 9x to the power of 6 minus 1, we can do our scratch work. I'll help you guys through this. If you know how to do this, go ahead of us by all means. So I have to find what is the square root of 9x to the power of 6, which is the equivalent. I'm going to skip a few steps and get to this step over here. It's the equivalent of asking what's the square root of 9 times x to the power of, x to the power of 6, all of this to the power of 1/2. I'm going to give this to someone new. I got to get some more hands. Sorry, I'm going to lower your hand, Caroline. If you haven't been called on, I'm probably going to call on you. Yes, Chewy, thank you. How do I do this? Square root of 9, x to the power 6 to the power of 1/2. You multiply. So first do square root of 9.
So you first do square root of 9.
What is the square root of 9?
3.
3, okay. And then remember the way that we do a power to a power is we multiply those powers. So I'm multiplying, what is 6 times 1/2?
3.
3. There it is. All right, so Chewy's taking the square root of 9x to the power of 6. And here, I'll do the easy part for you guys. The square root of 1 is 1. Whew, I did all the heavy lifting there, okay. 1 is 1. Okay, so now I have my a, I have my b again. My a is 3x to the power of 3. My b is 1. Plugging into our formula yet again gives us what? What goes here? A conjugate pair. Who's got it? Someone new. Sorry, I have to get everyone in here at least once. All the girls are in. It's going to be someone.
Mrs. Sandell, I have a question.
I'm also in there. I already did my card today.
What's your question, Beverly?
If it's like cubed, it would be the same way then?
If it was cubed,
Like it's 3x to the third
yes,
and not like 3x to the second?
exactly, yeah.
It's
3x,
the same thing?
yeah, so you're plugging in 3x to the power of q, or 3 for that spot. I don't know if that's the question that you're at.
Okay, never mind.
Wait, but then what would happen if you started out the original problem? It was like 9x cubed minus 1. How do you take the square root of x cubed?
Yeah, so what is the square root of x cubed? The answer is x to the 3/2, or you can say this is x to the 1.5.
Okay.
Those are kind of gross problems, so Khan Academy won't do that, but that is mathematically what you would do.
Okay.
Yeah, good questions. All right. Aurelio, help us out. What goes in these spots right here? Are you there, Aurelio?
Man, I don't know.
Okay, well, I'll tell you. So A is the first thing that we're going to write, and there's our A. So what's the first thing that you're going to read out for us?
Three x cubed,
Keep going. Follow the formula.
and then I don't know.
What's our next sign? So you just wrote A. Is it a minus, plus? What are we doing next?
Is it minus?
It is a minus, yeah, because we're just copying down our formula. So 3x cubed minus, okay, then B. What's our B?
Second one right there.
Second one right there.
Yeah, the mouse is on it right now.
The mouse is on it.
Yep, it's on B right there.
What's B? What number is B?
Power to 1 equals 1, whatever.
1, okay, keep going. And then what's our next binomial that we're going to write down?
Just write it again. Put a plus sign. I don't know.
3x to the power 3 with a plus sign. There it is. All right, and then we're done. Okay, so that's our review. Now we're going to get into our new stuff.
So proud of you.
All right, here we go. If you haven't been called on, you're still going to potentially be called on. Okay,
Oh, wow. I'm playing that game? That's sneaky, Mr. Sandell.
here's the formula that you have to have. It is A minus BI times A plus BI, which looks really similar, right? It used to be A minus B, A plus B. Now I just have an I in it.
Sneaky.
Sure, can you at least sneakily be on your phone? Thank you.
I'm using a calculator. Sorry.
Oh, okay. Got it. Thank you for using your calculator. But this is kind of cool because before, if I ever had a sum of squares, it was impossible to do. Now I'm saying it is possible. And that's a general theme of mathematics. If I ever tell you something is impossible, then you need to work out a way to make it possible. And it's using these imaginary or complex parts. So let's try it out. X squared plus 16. Who wants to try this for us? Essentially, it's the same process. I had A, I take the square root of it. I'm taking the square root for this operation to get to A. And from B squared to B, I'm taking the square root. I just need to plug in an I. I need to add an I to it, or really multiply an I. Who's got this for us? I'm going to give it to someone new until I get through everyone that's new. Sorry, Ellery. And then we can start going a little bit faster. I have almost everyone in here. Oscar, let's hear from you.
So, what am I supposed to do? X squared?
Yeah, exactly. So x squared, and then we're going to take the square root of that.
Okay.
What is the square root of x squared?
It'll just be x
Perfect. So we have x. Keep going.
plus 16.
So yeah, now we're going to take the square root of 16. What is the square root of 16?
That I do not know.
Someone help us out with fingers. Look at the cameras, Oscar. Fingers. What is the square root of 16?
Okay, 4.
4. There it is. 4. Okay, so you now, Oscar, have figured out your A and your B. Now plug them into the formula right here.
Okay.
We have x. Keep going.
X minus 4. Why does that have to be I though?
I is the thing that allows us to have a plus sign here.
Okay, so
Keep going.
I, and then do you have to square that or no? No, you don't, right?
Yeah, so this, here, let me move this A. This A, it was just talking about that term up there.
Okay, okay. And then you do X plus 4I.
Done. Yep. Oscar has solved this problem for us. There it is. Let me talk about why this works really quickly. So if I make my general rectangle real quick, shrink, shrink, and I put the sides as A minus BI and A plus BI, notice what's going to happen here. I have an A squared. Let me use a different color. I have an A squared for multiplying those. I have an ABI, a negative ABI, and then I have a negative BI squared, which again, if you ever have an I squared, it's -1. So I have a positive B squared. Sorry, B squared, I squared. Forgot the 2 B's, didn't I? And then I eliminate these 2 values and I just have A squared plus a B squared, which is our original formula here. So that's my mini proof for you guys. Okay, and I think the last person that needs to participate is Leo, and then we can get some more people. Okay, Leo, help us out. We're doing 81 x to the power of 10 plus 100. How do I solve that problem?
All right. So
I'm trying to factor. I'll help you by giving you the first step. So we need to find the square root of 81 x to the power of 10, which is the equivalent of asking the square root of 81 times x to the power of 10 to the power of 1/2.
yeah, I'm not gonna do it.
Square root of 81, Leo, you got this. Square root of 81.
I don't really know.
What times itself is 81? It's either, you can do it on your fingers. It's less than 10.
Square root of 81.
Yep.
9.
Yeah, there it is. 9, okay. And then when I do x to the power of 10 to the power of 1/2, this formula up here states a power to the power, I just multiply them. So it's 10 times 1/2.
10 times 1/2.
Yep.
5.
5. So 9x to the power of 5. So you found the square root of 81 x to the power of 10. And then the last one that you need to do is the square root of 100. Because that's our second number right here. What is that, Leo? Square root of 100?
10.
10. There it is. Okay. And Leo, the last thing that you need to do is just plug it into our formula. So I have a conjugate pair, so I'm going to set up my parentheses.
Is it 9x minus 5?
So 9x, say it one more time.
Negative 5.
9x to the power of 5, just up here. So I'm just recopying down 9x to the power of 5. And then I copy down the formula minus what?
Minus bi.
Well, what is b?
And b is 10.
10, so 10i. And then what's the other conjugate for this?
The same as that, but plus 10i.
9x to the power of 5 plus 10i. And then we have it solved. Go ahead and box it. Shrink. Thank you, Leo. All right, everyone has participated. Now I can get multiple people participating. So this one is going to be, it's kind of a review from Algebra 2, but we only touched on it a little bit, so I'm sure that most people have forgotten this one. If you have this memorized, that's awesome. So notice how I have an 8 to the power of an 8 and the power of a 4. It's half of the original leading coefficient, or leading power, I should say. So this leading term, the first term, had a power of 8, and then the second term is half of that. Whenever that happens, that means that you have something kind of special. It's a special form of just a normal ninja star. So I'm going to do this problem over here a little bit on the left, because I'm running out of room. It's just a normal ninja star, and I kind of ignore the fact that it's an x to the power of 4, or if you want, you can think of it as an advanced ninja star. It looks like this. X to the power of 4. You always take the middle coefficient here, or I say coefficient, the middle power. So this is really x to the power of 4 and x to the power of 4. And then if you remember from Ninja Star, I'm going to put 6 and 5 somewhere. Do you guys remember where it is? I can get multiple hands now. 6 and 5, where did I put those for my Ninja Star? No one remembers Ninja Star? How to factor? Beverly?
Okay, I think I remember. Would the 6 go on top
Okay.
and the 5 go on the bottom?
Yep. So does that mean I'm adding a 6 or multiplying a 6?
Wait, what do you mean?
Am I doing what two numbers add to 6 or what two numbers multiply to 6?
What two numbers multiply?
Yep, multiply to 6 and therefore add to 5. Thank you, Beverly. All right, now you guys tell me, this is the problem. What two numbers here and here are going to multiply to 6 and add to 5? That's your puzzle.
Can I try?
Go for it, Jaden.
Is it 3 and 2?
It is 3 and 2. Next time, please raise your hand, though.
Oh God, bro. Do I raise it like this, or do I use the dumb thing in here?
I'm literally just staring at everyone's camera on my computer, and then I'm using my
So
tab.
can I just put my hand, because I don't want to click the button every time.
Yeah, just raise your hand. I'm looking at just your cameras.
Okay, cool.
Yeah. All right. And then what do I do from here? I basically take x to the power of 4 plus 3, x to the power of 4 plus 2, and I'm done. So I come over here and say, this is x to the power of 4 plus 3, and x to the power of 4 plus 2. And I'm done. Notice that this might be able to be factored more if 3 or 2 were a perfect square, because then I'd have a sum of squares, but 3 and 2 are not squares. Okay, so you will have that trinomial for homework tonight. Just be wary that that is going to be in there. All right, so we have 2 examples. We have example 1 there, example 2, and then we're done. How much time do we got? Oh, not very much time. Okay, here we go. Which expressions are equivalent to x to the power of 3 plus 9x? So hopefully you have everything here written down already. Notice that A, B, C, and D all have factored out an x, which makes sense because that should have been our first step. If I factor out an x for our original binomial, I have x to the power of what? Who can factor out the x for us? Factor out an x. Who's got it? What's left over? Beverly, you've done it twice in a row. Sorry, I have to give it to. Oh, actually, no. You, Jaden. Go for it again, Beverly.
Would it be x squared plus 9?
X squared plus 9. Thank you. Cool. So now somehow x squared plus 9 is going to be factored more into 2 things. So how do we factor x squared plus 9? Or maybe you guys can just see, oh, that's A, B, C, or D. Does anyone see it? Sorry, Beverly, I'm going to give it to someone else. And Ellery, you can participate again if you want. It's been a while. Go for it, Ellery.
So if you use the sum of squares thing, then you can end up with B.
Can you say it louder?
If you use the sum of squares method, because you simplify out the x, so then you have x squared plus 9, And using sum of squares, b is equivalent to the equation.
Yeah, so B is one of the answers. But because it says which expressions, plural, are equivalent, we can select multiple answers. So there actually, in this case, are two answers. So A doesn't make sense because these two binomials, they turn into x squared minus 9, not plus 9 like we want. So it's definitely not A. And D is not correct because if you do plus 3i and plus 3i, you're not canceling out any of the middle term. So it's not going to be D. But this C isn't factoring anything. Notice that it's a subtraction problem. So if it's not a factoring problem, we have to actually check what it is. And let's do that. So if I multiply all these together, I'm going to first do x plus 3 times x plus 3. And that's Ellery's formula from the very beginning that she was talking about. Square the first, double the product, square the last. So square the first, x squared, double the product, 3 times x is 3x, double the product, and it's 6x. So plus 6x plus 9. That's just multiplying the x plus 3 times x plus 3. I still need to multiply the x through that. So I have minus 6x squared. That's going to turn into x to the power of 3 plus 6x squared plus 9. And I saw that minus 6x squared that I have to deal with. And notice that the 6x squareds are going to cancel each other out. 6x squared and 6x squared is gone. And I'm left with, oh, I messed up, didn't I? I should have had a 9x. I forgot to distribute our x into the 9 to get a 9x there. And I'm left with x to the power of 3 plus 9x right here, which is exactly the expression that I started with. The correct answer is B and C. Okay, I'm probably going to record the rest of the video for pre-calculus example number 2 in a bit. So go watch that video and do the homework on Khan Academy. Thanks, guys. That's the end of class. Question, Beverly?
Yeah, I have a question. How do you like know the difference between the difference of squares and the sum of squares? Like, what's the
Great question. So difference of squares is a minus sign because difference stands for subtract, and sum of squares is just a plus sign.
okay? And the sum of so if it has a plus sign, you add the I.
Exactly. Yep.
Okay.
Yeah, great questions. Cool. I'm gonna go ahead. I'm recording on the iPad now, so it probably sounds a little bit different. We're finished with example 1. We're on to example number 2. Notice that all of these multiple choice answers for A, B, C, and D, none of them are adding or subtracting. Their terms are always being multiplied, which is not the same as part C down here. Notice that we are subtracting something, so we actually had to multiply this out to figure out if that was the answer. If you ever see an add or subtract in Khan Academy, you do need to actually multiply those out, but luckily for us, all we have to do is factor. So I have this trinomial, which is very similar to the trinomial that we did over here in this example right here. So let's go ahead and ninja star this guy. So it's going to be an advanced ninja star. Here we go, advanced ninja star, where I'm going to take x to the power of 4 for these top right and top left spots. What two numbers multiply to 20 and add to 9? So multiply to 20, add to 9. And I go through all the factors of 20, right? What times what is 20? 1 and 20. No, it doesn't get to 9. 2 and 10, close, but not quite. 2 and 10 gets to 12 or 8. What about 3? No, 4 and 5. Ah, yeah, 4 and 5 will get to 9. Okay, so I do 4 and 5, and I don't need to do any negatives, so I come over here and say that this is equal to x squared, not x squared. What have I done here? I accidentally said it's x to the power of 2. It should be x to the power of 4 here because it's the middle power. Sorry about that. X to the power of 4, x to the power of 4. So it should be x to the power of 4 plus 4 times x to the power of 4 plus 5. So that is the first time that you can factor that, and that, hey, that's A. But there are all these other choices, and remember that you can have multiple answers in this case. So this x to the power of 4 plus 4, that is a square right here because this is an even exponent, and this is a square because that's 2 squared. So if I take the square root of each of those terms and then write them out, I'll have the square root of x to the power of 4 is just x squared. The square root of 4 is 2, so x squared minus, little bit of a mistake there. Minus 2i, and then x squared plus 2i. And then I still have my original x to the power 4 plus 5. Is that anywhere in here? Oh yeah, so that's b, right? And notice that c is not the same. I have a plus and a plus. They need to be a conjugate pair, a minus and a plus. So the answer is definitely not c. That was a common mistake that students will do. And then d is actually an answer too, and it's kind of weird to do the formula this way because technically 5 is not a square. If I square root 5, I'm just left with the square root of 5. But they also write the square root of 5 down there. So essentially what they're saying is take the square root of both of these pieces, take the square root of x to the power 4, take the square root of 5, and then rewrite the formula. So that now turns into two different factors, x squared minus something I, and x squared plus something I. And the something that I'm saying here is really the square root of 5, which normally would be like a number, like square root of 4 turned into 2. But in this case, they're leaving it as a square root. So this is going to be the square root of 2 and the square root of 2. What am I saying? Square root of 5. Square root of 5 and square root of 5. There we go. And that is indeed answer D. So the correct answer here is A, B, and D. All right, that's all I have for the notes. Make sure that you get your summaries, pictures in Google Note or Google Slides, all that jazz. I'll see you guys tomorrow.